In this video, I will show you how I make wooden, hollow, barley twist candle holders. If you would like to skip the next section that goes over the design, jump to 12 minutes 30 seconds to get to the CAD/CAM tutorial, or skip all the way to the machining section at 33 minutes and 4 seconds. So here's what the final design of the candle holder I came up with looks like. It has a total height of 6 inches. The base has a diameter of 2 inches. There is a 1/8 inch bead on the base. And the top of the cove, just above the bead, is 1.4 inches in diameter. And then the cove center is 1.4 inches from the bottom, and that cove center has a diameter of 0.9 inches. The twist itself, the outside diameter is 1.4 inches, and the twist has a length of a total of 3.7 inches, and this ends at the center of a upper cove, which has again a diameter of 0.9 inches. Then above that, the top of that cove has a diameter of 1.4 inches. There's a bead at the very top, another 1/8 inch bead. And then the very top of the candle holder itself has a diameter of around 1 7/8 inches and is 0.9 inches above the cove center at the top. So this gives a total height of 6 inches. And at the very end, there is a hole with a diameter of 1 9/16 inch, and it is drilled to a depth of about 1/8 of an inch. So in coming up with the design, I considered many different aspects of the candle holder and went through a couple different iterations. So I tried different diameters of the stock wood, spiral spacings, twist angles, designs for the base itself, designs for the top where the candle is held, different wood species, and different even candle holder or candle types to hold. I also learned a couple lessons along the way. The first is don't make the features too thin. So in this picture here, this top piece where the candle is held got too thin and actually came apart while I was cutting the features on the lathe. And so just watch out, and I had to tape it back on to try to fit the candle in there. So watch out for really thin pieces. Try to avoid those, especially when doing part by hand. Also, I learned to drill the top hole and the details at the very top first before drilling out or cutting the twists, because after the twists are cut, the piece becomes much more fragile. So this is the approach I took when creating the part. I knew I was going to use the CNC router to help with the twists themselves, but I also considered using a wood lathe for other operations. And so I ended up kind of with this hybrid method of making these pieces. So most of the design itself could be created on the CNC router, but it would require a considerable amount of time, as the machine would have to go back and forth to make the profile all the way around. And so I chose to do some operations on a wood lathe, because I thought it would be faster. And then some of the details were small, especially around the beads. That would make it hard to do with the router. And I also already had to drill the end hole by hand, so it would already be set up on the lathe and ready to go. So that also played a factor into deciding to do part of it by hand. So here's an overview of the steps I used in making this. So the first phase is mainly drill the end hole and then also rough out the shape by hand. So again, drilling the hole at the end first. And then I marked the very end of the piece. And so mainly I did this to have a reference point for when I loaded on the CNC. I could mark the 0 point of the candle holder. And then I roughed out the twist diameter, as there was a lot of material here to move, and so I can rough that out pretty quickly by hand on the lathe. Then I also added the bead and the upper details to the top area before I cut the twist, and then also rounded over the base area. And this was mainly to add clearance to the Barley twist bit when it was on the CNC. So the second phase was mounting the candle holder on the CNC router itself using the rotary axis. And so the initial phase of this was to use an end mill, and this end mill then would come down and plunge where the twist is, just to make sure this diameter was accurate. And so in case I was off by doing it by hand, this phase would clean it up and get it to the right diameter. And then used a Barley twist bit to cut the main twist shape. And finally, used the end mill again to cut between the twists, and this hollowed out the center of the part. And then phase 3 was to remount the piece back on the lathe and finish it by hand, so I could add the final details at the top and also shape the base itself. And then sand using 150, 220, and 320 grits, and then applied the finish while it was still mostly on the lathe. All right, so one of the interesting things about this design was that it is hollow. And so this kind of puzzled me at first a little bit, is how can the twist be hollow when it's only cut from the side? So after looking at this quite a bit, I am going to try to relay to you how this works. So one, I found out that it requires at least 2 twists before it is hollowed. There can be more. And I found it most easily understood by starting with a special case. So this special case is where the twist angle is 90 degrees. So essentially, they don't twist at all. It's just a slot cut in the twist area. So I'm going to visualize this using Fusion 360. So here is a cylinder just like our kind of candle holder piece. And so I'm going to cut the first special case of the twist, which is just a slot down one end, and you can see then this is not hollow at this point, and it's cut all the way to the radius. But if we add the second slot, you can see cut on the other side, and it goes all the way through now. So if we add the axis line in here, it makes it much easier to visualize that this center is indeed hollow. And so when we add a different twist angle, or these slots essentially just rotate along the circumference all the way down the length of the slot here. And so if you look at the end, you can see that features that are on the outside circle stay on the outside circle, and they just move around the outside circle. And intermediate circles, the features just get rotated around the center point all the way down to the middle. So near the middle, the features just rotate on the smaller circle. So what that means is all of the features around this axis in the middle just rotate around themselves. And since it's empty here, it stays empty because the empty parts just rotate around there. See, another way to look at this is if I just do a cross section here, you can see that all these parts in here would just rotate as the slot would be rotating around the circumference. So this middle section would actually just stay hollow. So I hope that helps a little bit. And then it turns out that the hollowed core ends up being the diameter of the bit used to cut the slots. And then if this didn't quite make sense, take a really close look at the time-lapse, especially the end view of when these slots are cut. And you can see that the CNC router, it'll plunge eventually all the way down to the radius, or all the way down to the very center of the piece, and it will go all the way down the length of the twist area. And so at that center length, it'll be cut the entire distance. And while this is going on, the rotary axis will twist. But then when it cuts the other twist, which is on the opposite side of the each of the other slot, it'll again cut all the way to the center and then rotate again on the A-axis. And so during that entire twist, there's always a cut from either side going all the way to the center, and that's what causes the area in the middle to be hollowed out. All right, so next we're going to move over to the CAD-CAM demo using VCarve Pro, and the steps are exactly the same for Aspire. In this, I made extensive use of the new features in version 9.5, specifically the G93 and the new Rotary axis job setup type. So I won't probably talk about the G93 much, but that is just a way to export G code that helps controllers like Linux CNC to properly convert linear speeds to rotational speeds. So without this, those controllers tend to take a really long time to do rotational moves. And some controllers have options to automatically compensate for this, but Linux CNC, which I use, does not. And so I have other videos on this topic if you're interested. And I even wrote a program to convert G94, which is the standard mode, to G93, which is inverse time mode. But now we don't need to worry about that anymore. If you just have a post processor that allows you to use G93 in the version 9.5, that's all taken care automatically. One other prerequisite before we switch over to the VCarve Pro is adding a custom bit. So I used a 1-inch Barley twist router bit from Magnate, and it's number 7751. And so this is a non-standard bit, and so I had to add this as a custom tool within VCarve Pro so that the preview would work properly. And so there are details on the Vectrix website if you go to this link, and there are frequently asked questions on how to add custom cutters. And to help you out with that, I have included in the description 2 different files. One is the project file I used for the specific form of the profile for the 1-inch Barley twist bit, which you can just open up and then quickly convert to a new custom tool. But if you're using a different sized twist bit or a different bit from them, here is a DXF file I'll also include that has a lot of the different profiles for those different router bits. All right, I've opened VCarve Pro and I've started a new design, and so I'm going to go through the job setup. So this is a rotary job type, so I've selected rotary. The length of this project is 6 inches, and the diameter, in my case, just a little over 2, so 2.025 inches. The Z0 for position for me is through the cylinder axis, and the orientation for my rotary axis is along the y-axis. So after that, hit OK. All right, and the first thing I like to do is drag some layout guides around the outside of the project. And then I'll do the layouts. So the first thing I'll do is lay out where the coves are located. So if I look back at the design, I see there's a cove center at 1.4 inches from the bottom, and then another cove center at 5.1 inches above. That's 1.4 plus 3.7. So I'm going to go add layout guides for both of those locations. So one at 1.4 and then one at 5.1. All right, and because the Barley twist bit is a diameter of 1, the radius on each side of from the center of these coves is going to add a 1/2 inch, and then to each side. So I'm going to offset these coves to make sure I get the full width of the cutter. And so I'm going to offset that so I'll bring that up again. I right click on this guide, and then I want to create a new parallel guide. So I'm going to do relative to this guide. And what I want to do is add 0.5. So I'm going to add the radius of the bit to it. And I'm going to add an additional 50 thousandths just as a tolerance. So when I get that bit in there, it's not quite so close to the edge. So I'm going to add 50 thousandths. So I'm going to create that new guide. I'll close this, and I'll do the same thing to the bottom one. Right click on the guide, and I'm going to create an offset relative to this one, And then, but in this case, I want to do a negative guide because I want it to be below. So create that. All right, so now we're set up for the area where the coves should be, as well as the outsides of the coves. And then the one last thing is to add a one additional guide, and this would be a guide for clearing out this area where the coves and the twists will be cut. And so because this is a wrapped job, I want to make sure that the clearing bit goes all the way across from one side to the other. So I'm just going to offset this side just slightly. So I'm going to offset this relative to this guide. I'm going to do a little bit more than the half the diameter of the bit I'm going to be using. So I'm going to be using a 1/4 inch end mill. So I'm just going to offset this by 0.15 inches. All right, so now I have laid out all the guides I need. And I'm going to now draw the clearance area. So this is the area I want to clear out to create the area between the top ridge of this cove through the cove itself, the twists, and then this cove down here. And this diameter is 1.4 inches. So this is the clearance area that I want to create. And so I'm going to draw just a rectangle. I'm going to start in this corner out here. And I'm going to go all the way down to the bottom of this one right here. All right, so that is the area that I'm going to clear out. Okay, so the next step is to add the spiral layout. And so to do that, there's a nice gadget. And so you go to Gadgets, Wrapping, and then choose Spiral Layout. All right, and this dialog will come up. And so with the number of strands is 2 in this case. And I also want to create a left-handed twist. And then I want to make sure I use a spacing between strands. So these values that I've come up with here for these two are just based on kind of trial and error and what looks good. And so I found that a spacing of 0.9 inches looked the best. So you probably want to have, at maximum would be the diameter of the bit you're using. And so I'm just doing a little bit smaller than the diameter. So that's 0.9 inches here. And I also want to make sure I'm doing create a cove at the beginning and the end. And then offset from the start. So this would be an offset from the bottom. And if looking at the design again, this cove is centered at 1.4 inches up from the bottom. So I'll type into here 1.4. And then offset from the end, that means offset from the top. And from the top, it is offset by 0.9 inches. So that's already entered in there. All right, then hit OK. And it tells you how many number of revolutions you get for the spiral, and just hit OK. And then all of the lines are drawn here, as well as the lines for the coves, which are hidden by the original box. So I can go over to layers, and I can change this color to, for the coves, we'll just go kind of a green color. And the spirals we'll choose to be orange so they stand out a little bit more. So if we hide the layer 1 where we drew the box, you can now see the coves in green, and the spirals are drawn in orange here off to the side. So they are off to the side over here, and they're not on our actual project, but that's okay because this is a wrapped project. So these spirals, as long as it starts in this corner here, it'll just wrap all the way around the project. So just think when it hits to this side, it just really continues back over on this side again. All right, I'll just turn all those layers back on. And so with that, actually all of the CAD is done. So this layout and the drawing is all done for this project. And we're going to switch over to creating the tool paths. So we'll switch over there. And so the first thing I want to do is cut out this area down to the 1.4 inch diameter. And so I'm going to do that. I'm going to use a pocket tool path. And I want to make sure that one is selected. Okay, so I have just that rectangle selected. And so I want to do a start depth of 0. And I got to figure out the cut depth. So I need this cut depth to end at, so I have that center diameter of 1.4. So I have to go figure out what that is. So I'll do that kind of over here in the scratch area. And so I know that I have a diameter of the piece, and that is equal to 2.025. And what I really want to solve for is this cut depth, C. So I know the total diameter is equal to the final diameter that I want is 1.4 plus 2 times my cut depth. And the reason it's 2 times the cut depth is because this is a rotary job. Anything you do to one side also happens on the other side. So this cut depth will happen on both sides. And so I really need to multiply that by 2 to get the cut depth. So then for this, I just solve for C. So C is equal to D minus 1.4 divided by 2. And so if I plug in 2.025 for D, then this gives me a cut depth of 0.3125. All right. All right, so back to this. I can just type that in. It's already typed in for me since I had practiced this before doing this capture. So I'm at 0.3125 for the cut depth. All right, so I'm going to select my tool. I want to select just a 1/4 inch end mill. Hit OK. Though for this, because of my rotary axis, it always seems to vibrate quite a bit. If I take too hard of passes, I'm going to up this to, well actually for this case, because I've already hollowed it out by hand, most of it, I really just want to do one final pass. So I'm going to put this down to 1, and this should clear, make sure everything is all cleared out for the right size before the Barley twist bit is used. So that's why I'm only using 1 pass for this. And it really won't cut too much as long as I'm fairly precise on roughing it out by hand. So do 1 pass, and then I'll just name this pocket main area. Let's say calculate. And we can simulate this, so we'll just preview the selected tool path. And there we go. So now this area is cut to where we want it to be. So we'll close that. And the next, we will cut the coves. So for the coves, it's really a 2D profile. So I want to cut this green line and that green line. So I'm going to select them both. And that is a profile path. So I'm going to select profile path. And the start depth should be the depth of what our last cut depth was. And so that is 0.3125. And then the stop depth is the depth of the profile of the bit. So I know this bit profile cuts down 1/4 inch. So I'm going to type in 0.25. Alright, so now I need to select the tool. So I'm going to select the specialty bit. So I've already set up the custom Barley twist bit in here with the custom profile. It has a diameter of 1, and I'm going to use a feed rate of 25 inches per minute and a plunge rate of 10 inches per minute. And then a pass depth of 0.0625. So I'll say okay, select this. And then, as I was kind of mentioning earlier, the rotary axis on my machine tends to vibrate a little bit, so I'm going to add an extra pass. So it's at 4, so I'm going to add, can be cut out quite a bit of wood at a time, so I'm going to just bump that up to 1 additional pass. And then we want to machine the vectors right on the line, so we want the cove to be right on those lines. So make sure that on is selected there. Then after that, I just need to name this. I'll name this Twist Coves and calculate. All right, now we can preview this toolpath. All right, it's looking a little closer to what we want. Close the preview, go back to the 2D window. Okay, so now I want to do basically the same cut as I just did for these coves, but use these twists instead. So I'm going to select both of these twists, and then select the profile toolpath again. And we'll do a start depth back the same as the original depth of that clearing area, which is 0.3125, and a cut depth of 1/4 inch. And I make this pass 5 again for the exact same reasons. And make sure the Barley twist bit is selected, and the machine vectors is on the line. And then we'll just name this Twists and hit calculate. All right, we'll preview these paths. And now you can see the nice Barley twist shape on the piece. All right, so the last cut we need to do is to do the hollowing cuts. So this would be cutting on these spaces in between the twists. All right, so for this, we also need to do another profile cut. So we're going to do a profile cut again on these two same vectors that we used for the twists. But this time we'll use a different bit. So we're going to do another profile toolpath. And the start depth here is equal to the original start depth, which is 0.3125. Plus we went a depth of cutting before of 0.025. So that would be at the very bottom of the coves. That is the current depth. But because the coves are not flat at the bottom, they're rounded up, I'm going to back off just a little bit. So I'm going to back off about 50,000. So I'm going to go minus 0.05. So the nice part about these fields here is you can just add equations, and then at the very end you can just hit equals, and it'll calculate it for you. So that's going to be my start depth is 0.5125, and then the cut depth here is, now I want to get all the way to the center of the piece. So for that, I know the diameter is 2.025, and since we're only working in the radius, because it's a wrapped piece, we have to divide that by 2. And then we need to subtract that start depth above, so that's 0.5125 But then I want to add an additional amount just to make sure we cut all the way to the center and we don't get a extra thin strand in the middle. So I found that adding about 30 thousandths works out pretty well. So I'm going to add 0.03. All right, then hit equals. And so that comes out a depth of cut of a little over a half an inch. And so I'm going to now select a different tool. So instead of using the Barley twist, I want to use a 1/4 inch end mill. So I select the 1/4 inch end mill and hit OK. And I want to make sure it's select on the lines. So 5 passes is pretty reasonable for this. So I'll leave that as 5. I'll use machine vectors. I'll do again on because I want to cut in between each of those twists. And then after that, I'll just name these just the hollow cuts. And then hit calculate. All right, and then I'll preview this tool, and you can see it cuts through all the way to the center. The 3D preview doesn't show that being hollowed. It's just an artifact of how this is wrapped and rendered. But it gives you a pretty good idea of what the part's going to look like. All right, close this, and then so we can get a time estimate by kind of hitting the summary of all these tools. And it shows here a total machine time of 51 minutes. I found running this on my machine, it takes usually about 25 minutes to do all three with all 3 bits. Of course, I have a scale here of 3.5 because some of the other operations tend to take longer, like V-carving and other things, so that's why I keep the scale up fairly high. All right, so next thing to do is just save this tool path out. So I hit the save. I make sure all of the tool paths are selected, and then I choose a post processor that is the wrapped. So this is wrapping all the X moves to the A rotary axis, and I'm using a G93 capable post processor. So I just save this out. I'll just save this to the desktop here. And I'll just call this Barley twist candle holder. All right. And with that, we're ready to go cut the piece. Start with a 2" by 2" wood blank. I am using walnut. Mark and cut the blank so it is 7½ inches long. And mark the center on each end. Then mount it on the lathe and turn it round. Fix the rounded blank in a chuck and drill a 1/8 inch deep hole on the other end with a 1 9/16 inch Forstner bit. Using a story stick, I lay out the main twist area and the end of the piece. Calipers help me quickly set a diameter of 1 9/16 inch at a few places. Then I rough out the main twist area to that depth. I periodically check the depth and layout. I used custom 3D printed tools to make it easier. I then round over the edge at the base and add the bead and details to the top. It's much easier to do this before cutting the spirals. Next up is preparing the CNC router to cut the spirals using a rotary axis. The first bit is an upcut 1/4 inch end mill. Using a block that is the precise height as the center of the rotary axis, I am able to quickly set the Z0 plane. To set the Y equals 0 plane, I use a custom laser guide, and for the X equals 0 plane, I use a predefined position since the rotary axis is in a fixed location. The first part of the program cuts one flat pass around the part to be sure the diameter where the twists will be is correct. I then switch to a 1-inch Barley twist bit to cut the main shape that consists of 2 end coves and 2 twists. For the last sequence, a 1/4 inch upcut end mill is used to mill between the twists. The cut goes all the way to the center of the wood in multiple passes. Because the bit cuts the length of both twists all the way through to the center, this effectively hollows out the center. It is back over to the lathe to finish the candle holder. I first finish the details at the top, then create the shape of the base. After I'm happy with the overall shape, I remove as much wood around the base as I can for sanding. I then sand on the lathe from 150 to 320 grit. I sand the twists with the lathe off. The finish consists of 1 coat of pure tung oil thinned with 50% citrus solvent, then 1 coat of 100% pure tung oil. Finally, I part it off. Next, I sign and date the bottom and apply a final coat of tung oil. Wow, this is a big mess. I know what to do. Ah, much better.
And snap! The job's a game.